Hi, this video's on section 2.1, organizing data. So let's take a quick look. So first we have all this data here. There's a lot of it. So I'm not going to memorize it, or I'll keep on referring back to it here shortly. And we're going to try to create something called a frequency distribution table. Frequency distribution table, and this is the start of a table. So what we do with data is all this data that we have up above here, we're going to put it in different limits, in little different categories. So we have something first called class limits, and we're going to figure out how to create this and all in a little bit. But right now we have class limits. So all the data from 27 to 35, that includes 27 and 35, get counted here. This is the little tally marks, little tick marks. So if you look at that, it says there's only one piece of data from 27 to 35. The frequency is 1. There are 3 pieces of data from 36 to 44. When we do 1, 2, 3, 4 pieces of data, the next line you do goes across. So that indicates 5. So you have 5 and 4. So you have 9 pieces of data. So if we go back to the top, let's look and find that one piece of data that fits between 27 and 35. 27 and 35, that one right there. There is no other data between 27 and 35. If you look, I don't see any other piece of data between 27 and 35. There's 38. That's too much. That's in the second limit. So that's the only piece of data between 27 and 35. So they did this for all the data, all these tick marks, and then they tallied it over. And then when they added up all these frequencies, there were 50 pieces of data. Once again, you can go up to the top and verify that there are 50 pieces of data. If you look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they're 1, 2, 3, 4, 5. 5 times 10 is 50. There are 50 pieces of data here. So if you added up all your tally marks and everything, and you ended up with 48, and you see you have 50 pieces of data, somewhere you went wrong. You skipped a couple of pieces of data. All right. So in the past, and just to show you, they took all those tally marks and they laid them on their side. You see there's the 1, the 3. They laid them on the side, and it kind of shows you the curve that could be formed from that. So you can put nominal or ordinal data. A level can be placed in these categories, organized, and put in a frequency distribution table. Let's try this next one. If we look at this, they gave us 25 Army inductees, had their blood types tested. See, these are the Army inductees. And if you look, there's 25 types of blood here. And if we're going to create a frequency distribution table, So we're going to create the types of blood first that are up here, types of blood. There was A, there was B, there was A, B, and then there was O. I think there were 4 types of blood listed there. Let's verify that. A, B, O, and AB, yes. So go through this and count the number of A bloods. 1, 2, 3, 4, 5. So there were 5 A bloods. I'm going to erase that just for a second. 5 type A. So the tally marks I would put in here would be, if I did this, there we go. This is our thing. There was 1, 2, 3, 4, and then 5. 5, so there's frequency of 5. And if we remember, there were 25 total pieces of data. Now, I don't want to go back and forth over and over again. So I'm just going to make these numbers up. I don't know how many B's. Well, maybe I should go back and actually do it. I'm going to go back and count the number of B's. B's were 1, 2, 3, 4, 5, 6, 7. So I count 7 B's. One, 2, 3, 4, 5, 6, 7. 7 B's. Now I'm going to check the AB's. 1, 2, 3, 4 AB's. 1, 2, 3, 4 AB's, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 O's. 4 AB's and 9 O's. One, 2, 3, 4 AB's and 9 O's. 5, 6, 7, 8, 9. So when you add these up, you should get 25. 5 and 7 is 12, and 4 is 16, and 9 is 25. So yes, they do add up to 25. So it looks like I put everybody in the right category, and I counted for 25. The next part talks about what percent of the blood taken was a percentage of O. Well, if you look, this is frequency. We're going to take the frequency, which is 5, divided by N. N is the total number. This is N, the total number in the sample. So it's 5 divided by 25 times 100. If you put that in your calculator, you get 20, and then I'm going to put the percent symbol. 20% of the people in that group had type A blood. Then I'm going to do the next one. Once again, it's frequency divided by, here's frequency, 7 divided by N, and is the total number, times 100. And I get 28% on my calculator. Then I do 4 over 25 times 100. I get 16% on my calculator, and I get 9 over 25 times 100, and I get 36%. So if we did everything correct, this should all add up to 100%. 20 and 28 is 48, and 16, 58, 64 plus 36 adds up to 100%. So it looks like we did everything correct. So this is the beginning of our frequency table, just tallying up the different data that we have. And we don't always have this percentage here, but we could. So the percentage, I would write this formula down then. The percentage equals the frequency in this category divided by the total number, the frequency in this category, this is the frequency, divided by the total number in the sample when you add up all the frequencies, times 100, and you'll get the percentage in each category. Type A blood has 20%. 20% of the people have type A. 28% have type B, 16% have type AB, and 36% have type O. Okay. So we call those frequency distribution tables. Now, when we have the class limits and the boundaries, then this is a grouped frequency distribution table. This is going to, it's forming more of a table, because now we not only have class limits, but we have class boundaries. And we actually talked about a boundary before. Remember when we had the number, we've done boundaries just for like individual numbers in one, I think it might have been 1.3, or yeah, maybe section 1.3. If we had the number 25, its boundaries, you do one higher or 0.5 higher, and then you subtract one and then add the 0.5. So remember the boundary for 25, you just tack on a 0.5. Then you, to get the lower boundary, you subtract one and then tack on a 0.5. 25 minus 1 is 24, and then put on the 0.5. So the boundaries for 25 is 24.5 to 25.5. So we've done that in a previous section. So here, if we have our class limits, already, the boundary then will be 0.5 more than the highest one. And see, this is the upper boundary and this is the lower boundary. This is the upper limit and the lower limit. So if we have 64, the upper boundary would be just add a 0.5 to the end of it. In the lower, you have to subtract 1. 58 minus 1 is 57, and then put a 0.5 at the end of it. So that's how we're doing all these. If we have the class limits, the boundaries are just putting a 0.5 at the end of it for the upper. For the lower, you subtract 1 minus 1, I get 64, and then put a 0.5 at the end of it. Okay, so just look at all the rest of these. The upper boundary is just a 0.5 more, and the lower boundary is subtract 1, which is 71, and you get 71.5. You put a 0.5 at the end of it. Now, there's another way of looking at this, and we're going to actually do one of these here in a little bit. But look at the class boundary here. If 64.5 is the upper boundary, then it's also the lower boundary of the next category. That's not like that in class limits. Class limits is trying to get it in the data in each category. The data 58 to 64 goes in this category, this limit. But the next limit starts with 65. So there's a gap between 64 and 65, but we don't have any decimal numbers. This is, the limit is what our data is. So our data is whole numbers. Our boundary always has 1 decimal more than our limits. So boundary has 1 decimal place more than your class limits. And the boundaries encompass, well, the limits encompass all the data. Pick a data, 75. 75 fits into this category. 71 fits into this category. From 58 to whatever the last number is, all the data fits into the class limits. the thing about the boundary is they tell you what the lower boundary and the upper boundary is. And for boundaries, the upper boundary is the same thing as a lower boundary. Since all the data here will be whole numbers, do you see a decimal doesn't matter as far as you can't put it in one of these categories because the number is going to be 65. Well, 65 fits into this category. Do you see 65 fits into this category? So once again, the upper boundary is the new lower boundary. The upper boundary is the new lower boundary. The upper boundary is the new lower boundary. So, I mean, you can do 92 and then tack on a 0.5. Then you know that's the new lower boundary. Subtract 1 from 93, you get 92, then tack on a 0.5. So if you have class limits, you should be able to calculate or write down, not calculate, write down all the class boundaries. So just have a little side note. Class limits, maybe I should write that down here. It's the same decimal place as data. In other words, our data is whole numbers because there's no decimal in there. Our class boundary has one more decimal place than our data. In other words, if our data is 24, if let's say our data, we have the number 24, then our boundary for 24 would be 24.5 and subtract 1 and add a decimal 23.5. Do you see our boundaries have one more decimal place to the right than our data does. This would be our class limit 24 up here. Down here, the boundary has one more decimal place. Okay. Once again, this is the rules here. The class limits have the same decimal place as the data. So in the book, it says that the class limits have the same decimal place as the data. The boundary should be one additional decimal place with a 5 at the end. So if it was 24, then it'd be 24.5, one additional decimal place. Now, the class width, that's very, I mean, quite a few people miss this on the quiz and the test. So they show you all these different ways of doing the class width. Oh, I would write down one and just understand it. So here's how to calculate the class width. First, you can do successive lower class limits. What you're just going to do is subtract the two. Oh, it says subtracting here. Subtracting lower class limits, upper class limits, or upper and lower boundaries. They don't have to be successive. See, these say successive class limits. So let's see what all this means here. Let's see what all this means. So successive lower class limits. Let's find the class width. Successive class limits. So first of all, once again, 58 is the lower class limit. The one on the left is the lower, and I just put LL, lower limit. The 64 is the upper class limit. Now it says successive, subtract the successive lower class limits. The width equals, this is a lower class limit, and this is a lower class limit. These are successive. They're one next to the other. It's the next lower class limit. So subtract them. The largest number minus the smallest number. 65 minus 58 equals 7. Our width, class width, is 7. It also says in the instructions, subtract successive upper class limits. It doesn't matter which upper class limits, subtract these two. This is an upper class upper limit. This is an upper limit. Two successive upper limits. 92 minus 85 equals 7. That's our class width. Okay. So you can subtract any two successive lower limits or any two successive upper limits. You can also, hang on, where's my pen? There it is. I'm going to use a different color. Then it says subtract class boundaries, not successive, just any class boundary here. So those were class limits, but these are class boundaries. Subtract those two. 78.5 minus 71.5. And when you put that in your calculator, you get a class width of 7. Do you see I got 7 for all this? Find the class width. You can subtract any two successive lower limits. You can subtract any two successive upper limits, or you can subtract any class boundaries. They don't have to be successive there. They have to be the actual class boundary. So that's how you find your class width. And let me show you, a lot of people mess this class width up. This is how I also do class width. Class width is or equals how many data points can fit into this class. So do you see on this first class limit, 58 fits in there, 59, 60, 61, 62, 63, and 64. Do you see all right here, which data points can I pick, tally up in that spot? Number 58, number 59, number 60, 61, 62, 63, and 64, because that's the class limit from 58 to 64. If you add those up, there's 7 of them. That's our class width. So that's another way of doing it. Look at all the pieces of data that fit in the limits, and there are 7. People make mistakes by subtracting the class limits. If you subtract the class limits, you only get 6, and that's wrong. That is wrong. You can subtract the boundaries and get 7. The class limits, you have to subtract successive class limits, upper or lower. All righty. The class midpoint, let's read through this. Oh, this was something else, right? I want to go back up here. Okay, the class midpoint can be by calculating the upper and lower class limits or boundaries. So it says either one. So the class midpoint, and I would definitely write this down. This is, by the way, this is in the homework and probably on a test or a quiz. You have to know class width. up here, what we just talked about. Now the class midpoint, it's the piece of data in the middle. The lower limit plus the upper limit divided by 2. That's the class midpoint. The lower limit plus the upper limit divided by 2. So in this problem here, down here, find the class midpoint. And once again, the upper limit plus the lower limit divided by 2 is your midpoint. And it doesn't matter. Let's pick this class limit. The upper limit is 71. The lower limit is 65. 71, 65. Add that up and divide by 2. 136. So it's 68. In other words, let's put these in order from 65 to 71. 65, 66, 67, 68, 69, 70, 71. There are 3 numbers smaller than 68. There are 3 numbers larger than 68. The class midpoint is 68. Okay, so the class midpoint, the middle of that class, is 68. So we're starting to get these formulas together. I would create this formula sheet so you have easy access to it on a test or a quiz, because by the end of the semester, your formula sheet is going to be crazy. And you can't be going through the workbook for every test. You think you can, you won't have time. You're going to panic and you won't be able to find anything. So the key to this class is be very organized. The key to this class is to be very, very organized. Have a formula sheet with everything on it that you need. So that was the class midpoint. So here are the rules for creating your own frequency distribution table. So we're actually going to do this, I believe in week 4, I have an assignment in class for you to do. So it's really important that you understand how to do this. You're going to create your own frequency distribution table. So it says if you're going to make a frequency distribution table, here's some rules. You should have 5 to 20 classes. So you should have 5 to 20 rows, classes. It could go 6 to 11, 12 to whatever, just keep on. There should be between 5 and 20. The class width should be an odd number. So that's kind of important. The class width should be an odd number. That helps on the midpoint. So the midpoint is not a decimal. If your width is an even number, then your midpoint should be a decimal. But it really helps. It says your class width should be an odd number. Doesn't say it has to be, but it should be. This ensures the midpoint for each class has the same value as the data. In other words, the midpoint is not a decimal. If the class width is an even number, then the midpoint will be in tenths. Yeah, the midpoint will be a decimal. When you do we do this frequency table when we graph it, we don't want those decimals. We want the midpoint to be a actual whole number. But like I said, if it can be a decimal if we had to. Once again, here's the formula for the class midpoint that we just wrote down a little while ago. The classes must be mutually exclusive. Give me a second, I'm trying to. Okay, so if you look at this, mutually exclusive, these are the class limits. The classes There are no overlapping class limits, so the data cannot be placed into two classes. Do you see the number 20? Let's say I have some data. I have data 11, 19, 20, 23, 30. 11 falls into this category between 10 and 20. 19 falls into this category. 20. Well, 20 could go here or go here for, for a class limit if these are limits. Do you see? So this is not a good set of class limits. They show you two separate class limits. So that's not good. Over here, on the other one, 11 fits into here, 19 fits into here, 20 fits into here. It can't fit into this one because we have 21. Remember, class limits go from 20 and then the next number down. It's the boundaries that have the same number. So I want to go up and show that up here. Remember the class limits, 64, then you go to the next number, 65, 71, then you go to the next number, 72. The class boundaries have the same number, but the limits go in the next one. So we know which piece of data goes where in the class limits. The piece of data is the whole number. The class limits will be the same as your data. Boundaries, they add a decimal place so it fits into it. All right. Okay, so the class limits must be mutually exclusive, no overlapping data. So the correct one is this one. This is not correct since 20 is 20 here. If you have 20 for a limit, the next one is 21. If you have 31, the next limit is 32. If you have 42, the next limit is 43. The classes must be continuous. There should be no break in numbers. The class must be exhaustive. That just means there needs to be a place for every data point. So if you have those class limits, let me just show you up here. If we have these class limits right here, let's say our data was 19, 27, 36, 55. 19 fits into here, 27 fits into here, 36 fits into here. 55 does not fit, it must be exhaustive. So the next, if for 55 to fit in here, you'd have to start off 54 and then go to the next number. 32, 42, 43, 53, 54, 64. So do you see exhaustive? That means all the data needs to fit in. If it doesn't fit in, then you didn't exhaust the limits. The limits are not long enough. The classes must all have an equal width. That's kind of important. The classes must all have an equal width. And that just prevents a distorted view, so your graph is not uneven or it misrepresents the data. So once again, this is the procedure. When I ask you, or the homework asks you, to create a frequency distribution table, you're going to come here and read the instructions. Step 1, find the highest and lowest values in the data. the data's highest and lowest values. Find the range. Okay, so now I'm going to give you the formula for range. Range equals the highest piece of data, subtract the lowest piece of data. That's it. So range is the highest piece of data minus the lowest piece of data. Select the number of classes desired. Remember it said 5 through 20 classes. So you have to select what you want. Usually on a homework or a test or a quiz, they tell you we want a certain amount of classes, 6 classes, 7 classes. So if they tell you, that's great. If not, you have to pick a number between 5 and 20, as far as where you don't want the data spread too far. If you only have like 10 numbers, you want to maybe have 5 or 6 classes. If you have 1,000 numbers, you want to have more classes because the data will fit in there better. Or it'll look better when it fits in there. Select the number of classes. That's usually given to us. Find the width by dividing, finding the width by dividing the range by the number of classes and round up. Okay, so we're going to look at this here in a second. We'll look at that in a little bit. Select the starting point. The lowest value of n is our starting point. That's a good thing. Is always our lowest data value. Our starting point, you should always start with the lowest data value. And then add the width to the lower limits. Find the upper class limit, find the boundaries, and then you're going to do the tally marks and all that. So we're actually going to do one of these. If I can get back to it. Once I click on a button, it fast forwards. Trying to get there. Okay, so. Still trying to get there. Okay, so step 2 then would be tally the data. Step 3, find the numerical frequencies for the tallies. Okay, so we're going to go back. Here's the data we're looking at. And it's going to go through the steps with us. If we go back up, once again, I want you to highlight this part in your workbook, procedure table. So we're going to determine the classes, find the highest and lowest values. That's the first thing. And they were so kind to mark them. Look at all this data they wanted us to do. Oh my, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 50 pieces of data here. This is the lowest piece of data, the smallest data point, and this is the highest. They were so nice, so we didn't have to look for it to highlight them. And we want to find the range. So to find the range, remember, it's the highest minus the lowest. Highest minus the lowest. So our range is 34. So let's just remember that. Our range is 34. It's really hard to do this on this Zoom with, normally I do this on a big board. And remember, I told you they'll usually tell us the number of classes. So here are the number of classes. they told us we have 7 classes. The number of classes, so they'd say, hey, we want 7 classes. So the formula to find the width of each class, the width of each class is the range, right here, divided by the number of classes, Our range, we said, was 34. The number of classes is 7. When I put that in my calculator, I get about 4.9. Well, if you get a decimal, you always have to round it up to the next to find the width. So this is, we're trying to find our width. You always round up. Just in this, for when you do class width, you always round it up to the next whole number. 4.9 rounds up to 5. So just to show you this, this is really important because a lot of people mess this up. Let's say it was, where's my calculator at? Let's say it was 30 divided by 7. So this is extra. So no, this is not part of the problem. But let's say it was 30 divided by 7. I get 4.28 on my calculator. You still round it up. Even though the next decimal is a 2, you still round it up to 5. You always round it up to the next whole number when you're doing class, the width of the class, okay? So our range is 34. Our number of classes is 7, and our width is 5. So we need to write all this down. I'm going to put it over here on the side. So just so we remember, our range was 34. Not that that really, our width is 5 because we rounded it up. Number of classes is 7. Okay, so I just put that there on the side. Watch me end up erasing it all by accident. All right, so let me, now that we have all that. So that's all, everything you have to do right at the very beginning if you have this problem. Because your paper is going to be blank and you have to put this down here. So select a starting point. Well, our lowest value, remember the starting point is the lowest piece of data we have. The smallest piece of data is 100. That's our starting point. So here, our starting point is 100. If you notice, that's our starting point, 100. Start with smallest piece of data, lowest data point. Okay, so now remember our width is 5. How do you calculate class width? By successive class limits. So I know now 105 comes down here. Do you see? 105 minus 100 is 5. Our class width is 5. Remember, successive class limits tell you the width. If 105 is here, then I'm going to put 110 here. 110 minus 105 is class width of 5. All the class widths have to be the same. And if we look, they have this table kind of filled in to see if you can make a mistake or not. 115 minus 110 is 5. 120 minus 115 is 5. So then the next thing would be 125 and then 130. So we have all our lower class limits done. Now the upper class limits, remember, if 105 is our lower class limit for the second class, then we have to have 104. Do you see in the first class, you have to fit in all the data. It can't be the same as the lower class limit for the class limits. Here, if this is 110, this has to be 109. And once again, if you subtract these two, you get 5. And so that's what we're going to do. We're going to just fill in the rest of this table. And if I have 115 down here, then I have to have 114. Or you could just add 5. 119, 114 plus 5. 119 plus 5 is 124. That's not right. Something went wrong there. What? Yeah, 119. Oh, I got it in the. I have it in, but I put it in the wrong spot. I cramped things up together right there. 124, 129, 130. Add 5 and you get 134. So if you notice, 134 is the highest piece where my data fits. There should not be any data higher than 134. If we did everything correct, there should not be any data higher than 134. When we come up here to our data, look, the highest data is 134. Now, that lower class limit, or that upper class limit for that last one, it just happens to be the same as the highest piece of data, but it doesn't have to be. But the highest piece of data has to fit into that last, into a limit. It has to fit into a limit. So that's important, and it does. In other words, it's exhaustive. All the data fits in. So next we have to do the boundary. So I'm hoping everybody pays attention, because I mean, this, you're going to have to be able to do this, exactly what we just did. The class boundaries, remember, is a 0.5, the upper. This is the lower limit. This is the upper limit. Boundary, this is the lower boundary, the upper boundary. The upper boundary is just 0.5 more, 104.5, 109.5, 114.5. Do you see how easy it is? 119.5, 124.5, 129.5, and 134.5. It's just 0.5 more than the upper limit. Now, if you remember, the lower boundary is the same as the upper boundary of the previous one. So 104.5 goes here, 109.5, 114.5, 119.5. Sorry, I'm a little messy here. I'm going 104.5, then 109.5, well, yeah, definitely. I'm not, my lines are off. So 114.5, then 119.5, 124.5, 129.5, and then we have 134.5. So that looks, the only thing we don't have is our first lower boundary. And our first lower boundary is 1 less than this. 100 minus 1 is 99. And then you put a 0.5. Remember how to find that first lower boundary. It's going to be 0.5 less than the lower limit. And then you go ahead and do the tally marks. You go up there and find out which pieces of data fall into this category and do the tally marks. I'm not going back and forth to do that. I think they did that all for us. Let's scroll down. That really is cumbersome, and you do have to practice that to get it correct. So if we look, they just give you more boxes to work this out. This is the class limits that we calculated. There's the data. There's the same class boundaries that we just calculated. And then they did the tally marks. Hopefully we got all the same thing. It looks like we got all the same stuff. Then they did the tally marks. And once they did the tally marks for each of the ones, you notice you have 2, frequency of 2 here. 5 and 3 is 8. 5, 10, 15, 16, 17, 18, 13, 7, 1, and 1. When you add up all these, I get 28, 38, 41, 47, 48, 49, and 50. I get 50 pieces of data. When I add them all up, that's exactly what we said we had. We had 50 pieces of data. Okay. And oh, okay. So that's really important. So this is what the frequency looked like. Once again, 2, 7, 18, 13, 7, 1, and 1, and it added up to 50. So that's frequency. However, some tables not only ask you for frequency, they ask you for cumulative frequency. Cumulative frequency is a running total. So in frequency of 2, we have 2. Now, if in the next CAD limit we have 8 more, 8 plus 2 is 10. Do you see? It's a running total. So cumulative frequency, you're adding the next one. If I added these 2 and I got 10. Now I have 10 and I have 18 more. So 10 and 18 is 28. Then I add 31 to it and I get 41. Then I add 7 to it. I get 48, add 1, I get 49, add 1, and I get 50. So do you see the frequency just says in each category, in each limit? The cumulative frequency is a running total as we're going down. We're adding them up as we go down. So that's the difference between frequency and cumulative frequency. Cumulative frequency is a running total. All right, so now here are some sample homework problems. Let's take a look at this. So it says find the class boundary. They don't tell you this, but this is a limit, a class limit. To find the boundary, remember you go 0.5 more, 61.5, that's your upper. The lower, you subtract 1, put a 54 here, and then put a 0.5. Class midpoint, we subtract the 2 and divide, well, the class midpoint is we add up the 2. Let's go back up to the formula. Remember, the class midpoint is you add the 2 up. That's why it's so important to have these formulas right in front of you. I got to go way up here to do the class midpoint. Where? Way up here, somewhere up here. Class midpoint, the lower limit plus the upper limit divided by 2. So keep a running account of all the formulas that we're having. Make sure you keep some formula sheet with all your formulas on them. So once again, our boundary was 61.5. 0.5 more than this. Subtract 1, and we get 54, and then add on a 0.5. The midpoint, you add these 2 together, 54.5 plus 61.5, and then divide it by 2 on your calculator. 54.5 plus 61.5 divided by 2, and you get 58. So 58 is the middle piece of data. That's our class midpoint. And our width, our class width, I'm going to give you a second to try to do it. Let's see if you can get it. I'll give you a second. So there was a couple of ways of doing it. Remember, you can do successive class boundaries. If this is the upper boundary of 1, then you can do 61.5 as the lower boundary of the next and subtract those two. 61.5 minus 54 is 7. So our midpoint, we said, I believe we said was 58. And our width is 7. Another way I like to do it is look at our limit. Remember, this is our class limits. 55 goes in there, 56, 57, 58, 59, 60, and 61. These are all the pieces of data fit in there. 1, 2, 3, 4, 5, 56, 57, that's a 58. 1, 2, 3, 4, 5, 6, 7. Do you see there's 7 pieces of data? That's our class width, 7 pieces. Successive boundaries, or you can add up all the, or the next limit, by the way, would be 62, or you can do successive limits. All right. Okay, so that's it for the day. I mean, they had more examples here. Actually, let's do this next one because this is one we haven't done yet. It's a little different because it has the decimals. So find the class boundaries, midpoints, so they don't tell you, once again, this is our limit. This time our limit is a decimal, and it's 2 decimal places. So our class boundary, our upper class boundary, is exactly the same as you see it there, except one more decimal point. I'm going to add a 0.5 to the end of it, or a 5 to the end of it, since it is a decimal already. Do you see how you do the next limit? You just put a 5 on the end of it if you have decimals. Here, we're going to have to subtract 1 from this, or 0.01, 1 from the last digit, and I get 5.11. 5.11, and then you tack on a 5. So that's the class boundary, 5.115, 10.485. If you're dealing with decimals, you still do the same number, but put a 0.5 on it. Same number here for the lower, just subtract 1 from the last digit on the right, and then tack on a 0.5. The class midpoint, once again, so this would be 10.485, the next class boundary, the lower class boundary. Subtract those two for the midpoint, 10.485 minus 5.115. Calculators do come in handy. 10.485 minus 5.115, and I get a midpoint of 5.37. Wait, that doesn't sound right. What did we just do? Oh, the midpoint. That's not right. They're asking for the midpoint, not the actual width. I just calculated the width, by the way. I think that's the next one down. Yes. Sorry. Let's take a look at this one again. So the class boundary was 0.5, a 5 at the end, 10.485. Subtract 1, 5.11 from the last digit, and then tack on a 0.5. The midpoint is adding the two together, sorry. The midpoint was adding the two together and dividing by 2. 5.115 plus 10.485 divided by 2, and I get the midpoint is at 7.8. So that's the midpoint of this data. And finally, the class width, if this was the boundary, then 10.485 is the lower boundary here. The boundary, you then subtract those two, 10.485 minus 5.115. 10.485 minus 5.115, and I get a class width of 5.37. All right. I hope this video helped. Know how to set up this frequency table from scratch. You have the number of data. You tell somebody gives you the class, the number of classes. Then you have to create the entire table. So know how to do that. That is really important. I usually do a quiz on that. I hope this video helps. Let me know if you need anything.